My name is Csilla and I'm going to talk about how can we protect our brain with ketones. Before we start, I have to disclose that what I'm talking about is not a medical advice. As I mentioned, I'm co-owner of Ketone Technologies, and the science I'm going to show you today basically inspired me and motivated me to establish the company Audacious Nutrition to create products that we can actually benefit from all the science that I'm going to talk about. I'm also inventor on several patents that I don't own these patents, the university owns them, but I have to disclose that I'm an inventor. So first I'm going to talk about the experiment, how I became involved with ketone research and neuroprotection. Second, I'm going to talk about neuroprotective mechanisms of ketones and how can it be applicable for a healthy and diseased brain. And finally, I'm going to talk about different metabolic therapies and some common misconceptions about ketones. So 14 years ago, I moved to the United States from Hungary after completing my neuroscience PhD, when I was hired by the CEO of the Alzheimer's Institute and at the University of South Florida. And soon later, I became involved in ketone research in Dr. D'Agostino's lab, when his lab was mainly focusing on hyperbaric experiments that were funded by the Office of Navy Research, and research was focusing on CNS oxygen toxicity seizures. So we basically put rats in the hyperbaric chambers and put under pressure to simulate diving. And after a while, when they were breathing oxygen, they got seizures. And the project was to find out how can we protect the brain to prevent these seizures or predict these seizures. How can it be applicable? This problem can happen for special operation divers. It can happen during hyperbaric oxygen therapy, for example, when people get it for wound healing, diabetic wound healing. And also very specific scenarios. For example, we did a NASA mission, NASA Extreme Environment Mission Operation, when we lived underwater for 9 days in an underwater habitat to simulate a space mission. My husband did this in 2017. I did this mission in 2019. And here you can see Samantha Cristoforetti and Jessica Watkins. They were also the crew on this mission. They were up on the International Space Station since then. And basically, we are preparing astronauts during these missions to go in space. So the point here is that to be able to come back from these underwater environments after 9 days living there, we need to breathe oxygen under high pressure. So again, the problem is there. How can we protect the brain not getting seizures, these oxidative stress-induced seizures? Until 1967, it was thought that the brain mainly uses glucose for fuel. Around that time, these nice people did a study where they fasted subjects for 40 days. This is a kind of study that you couldn't do today due to ethical reasons, but back then it was okay, I guess. So they were fasting for 40 days, and what you can see is that their glucose level was dropping, but their ketone levels were rising. And surprisingly, it turned out that the brain, 60% of the energy was coming from ketones and not glucose. And these ketones were beta hydroxybutyrate, BHB, and acetoacetate. And I'm going to talk about those a little bit later. So changing. Okay. So the next phase of the experiment was that they gave insulin to these people. And surprisingly, even during severe hypoglycemia, they were completely asymptomatic. So the ketones actually preserve the brain metabolism even during very severe hypoglycemia. Now we know that the ketogenic diet is used to raise the ketone levels, and it's used for pediatric seizures sometimes, and it proves to be very effective for drug refractory patients. And the Charlie Foundation is a very good resource to get more information about this topic. But the Office of Navy Research didn't like the idea to use the ketogenic diet for the special operation divers. So they wanted to have the ketogenic diet in a pill. So my husband came up with the idea to use a butanediol and a butanediol acetoacetate diester to test. And surprisingly, we found while the butanediol was completely ineffective, the ester was very effective to delay these seizures when we put the rats in the hyperbaric chambers. So later, I decided to try other ketone supplements, other combinations of ketone supplements as well, such as half dose of ketone ester mixed with MCT, medium chain triglycerides, and ketone salts mixed with MCTs. And ketone salts are basically the BHB molecule that I was talking about combined with minerals or electrolytes. And I found that the mix of the ketone ester and MCT was most effective to delay the latency to seizures, and also the severity of the seizures were reduced. We also found correlation between the latency to seizures and the acetoacetate and BHB concentration. So these correlations were very promising. And so the next experiment, I wanted to try that these ketone supplements, because they are basically an efficient fuel source, can they improve motor function? So I designed another experiment where I tested if the ketone supplements could improve endurance of the rat. And there were different scenarios, different age groups, different administration types. I'm not going to go into details, but they did improve endurance. But also, I found a very interesting thing that the supplements not only increased the BHB level, but they also reduced glucose level. And I'm going to talk about it a little later, why is it important that we can reduce the glucose level. This is another experiment that was very interesting and led to an accidental discovery. Basically, I was working with GLUT1 deficiency syndrome mice. They have impaired movement after a certain age, and we tried to rescue this phenotype to give the ketone supplements to them to see if they don't get paralyzed or just later in time. So every week I was measuring their performance, and I was also measuring their blood ketone levels when giving them the supplement. And they kind of freaked out when I was getting the blood from the tail. So I'm like, oh, I just put them in the anesthesia chamber from a couple of seconds. So they calmed down, and I calmed down. And I noticed that the ones that were getting the ketone supplement, they just didn't want to go to sleep. They were still running around, but the control was like long sleep. So I'm like, what if this is kind of a neuroprotective effect of the ketones that's protecting the brain from the harmful gas? So I designed a specific experiment experiment for that when I put the mice to these anesthesia chambers and video recorded everything. And indeed, it turned out that with ketones, there was an increased latency to anesthesia. So indeed, it is likely that the ketones protected their brain from the anesthesia gas, and probably it could protect the brain from other harmful gases as well. Another interesting, again, accidental discovery, what I saw, this is how I tested the rats to study their performance and endurance. Basically, it's, this equipment, it's called rod. So we put the rats on the rod, and the rod starts spinning faster and faster, and they run on this rod, try to stay on it as long as they can, because they have an instinct that they have a fear of height, which I can kind of relate. So they try to stay on the rod as long as they can, so they don't fall. So this is how we can measure, and then we give them different substances to see if we can extend their time on the rod. So again, I started this experiment, gave them a lot of different ketone supplements, and I noticed that the rats that were getting some of the ketone supplements, they just look down, they didn't care, and they jump off. You're supposed to be scared. So, again, this inspired me to design another experiment specifically to study anxiety. So there is an established method how we study anxiety. It's called an elevated plus maze. So you have two runways basically that are open, and these are also elevated, and two runways that are closed with walls. So obviously the rat, if it's anxious, then it spends more time in the arms that are closed with walls. And if it's not anxious, then it will spend more time on the open arms. And yes, indeed, we found that, again, I'm not going to go into details. You can look at the publication, which scenario and how it turned out. But some ketone supplements were more effective than others, but they indeed reduced anxiety in these rats. Since then, there is a whole new scientific field, metabolic psychiatry, that focuses specifically on this, how ketones can help anxiety and other psychological disorders. And this experiment was, for me, the most exciting, and this inspired me to then develop products because I think it's very impactful. So I was culturing brain cells in a petri dish, and I scratched cell cultures to simulate brain injury. And some of the cell cultures were just controls. The others got sodium beta hydroxybutyrate powder mixed in the media, and I monitored for 24 hours, took pictures with a microscope every 15 minutes, and after that I took a time-lapse video of this 24-hour period. And what I saw is that the cell cultures that were treated with the BHB, they had way more cells migrating into the damaged area compared to the control. So here you can see the blue is cell nucleus, the green is the tubulin. So the cell cultures that had the BHB had more microtubulus. The red is the synapsin, which is indicating how many new synapses are forming. You can see the control. In the red, you don't really see anything, me either, because there's nothing happening there. And the cultures that had the BHB had more synapsin forming. So here are some numbers. More synapsin and tubulin was found in the BHB treated cultures, but also what was very interesting, the cell migration velocity, the cells were moving around faster. And this is just a short video showing this is a control over 24 hours. This is what was happening, not much. And this is the BHB treated. You can see the cells moving around like crazy, growing processes, and pulling together the damaged area in the middle, almost completely closing it. So this experiment inspired me. Okay, we have to take this molecule. So some of the neuroprotective mechanisms I'm going to go through quickly, how ketones offer neuroprotection. First of all, we already know it's a high energy fuel source. When there is impaired glucose availability, for example, due to neuronal injury or neurodegenerative diseases, the brain ability to use glucose decreases, but it can still use ketones. There are several studies showing during traumatic brain injury, when they introduced PhD, improved the outcome. And also we know that it improves mitochondrial function. When ketones are used, 28% more ATP, more energy is generated by the mitochondria compared to glucose. Ketones also have gene expression modification ability, so they will upregulate genes that are involved in mitochondrial metabolism. They improve cerebral blood flow, so they measure then all measured brain areas. The ketones increase the cerebral blood flow. They also increase BDNF production, the brain-derived neurotrophic factor. Why is it important? Because this molecule helps to sustain the viability of the neurons, helps to develop new connections, helps when there is a injured area, helps to repair the brain. And we heard a lot about stress today. Unfortunately, the BDNF gene is suppressed by stress. So we definitely want to elevate it with the ketones if we are under stress, and it's generally low during depression. Ketones also reduce oxidative stress and lower ROS production and increase ROS elimination. They also help to reduce inflammation. So many neurological problems such as strokes, migraines, seizures are associated with brain inflammation. We now know many studies are showing that ketones have anti-inflammatory effect through different pathways. And interestingly, there are two different beta-hydroxybutyrate molecules, the D and the L, and it was found that the L stays longer in the bloodstream. So if you want to treat inflammation, then you probably want to do something, use something that has L-BHB in it. Ketones can also lower blood glucose. As I mentioned before, this can be very important for many scenarios. For example, when there is a brain injury, hyperglycemia is an independent predictor of the outcome, and it's not a good outcome. So we definitely want to lower blood glucose when we have a brain injury. Ketones also modulate neurotransmitter release. So when GABA and glutamate neurotransmitter are in balance, then our brain is okay. But if we have too much glutamate, then we experience anxiety and all the other migraines and issues. So with ketones, the L-glutamate will turn into GABA. The GABA level will increase, so we have improved mood and calmer brain. So what are the applications of these? So there are several emerging and also established applications that we already know of. The first and most obvious is Alzheimer's disease, mild cognitive impairment, and Parkinson's disease. So as I mentioned before, with age, the brain's ability to use glucose declines. There will be an energy deficit. The image on the left is a normal brain. The yellow and the red areas are showing where the brain is using glucose. The image on the left is an Alzheimer's brain. You can see that the brain uses much less glucose, fewer areas can use the glucose. So in these scenarios, ketones can stimulate the brain energy. On this image, you can see how healthy adult control brains on the top, mild cognitive impairment in the middle, and Alzheimer's disease brain on the bottom. On the left, glucose utilization. Again, the red-yellow area is the more intense. As you can see, as you go down, the Alzheimer's brain is using less glucose. But if you look at the right side, the ketones, the Alzheimer's brain can use ketones more intensively, which is a good news because this means that the cells are there, the brain cells, the glial cells are there, they didn't die, they are just not able to use glucose anymore, but they can use ketones. So there are a couple of studies. For example, they used MCT supplementation, which was mostly effective in ApoE4 negative patients. A couple other studies where they used MCT oils, different kind of MCT oil, but mostly it was effective in ApoE4 negative patients. And I know some of you know her. If not, I recommend to look up her work. Dr. Mary Newport published several books about Alzheimer's disease and ketones because she started treating her husband with coconut oil, medium chain triglyceride, and exogenous ketones to help with his Alzheimer's disease. Mild cognitive impairment, again, there were several studies where they used either the ketogenic diet or MCT formulations, and so improved markers, especially in verbal memory. For Parkinson's disease patients, again, they showed they studied a couple patients with ketogenic diet. The first study was only 5 patients, that's not much, but still they showed some improvement with the diet. Later, a couple more ketogenic diets, only with a little bit of elevation of blood ketones, but still they saw improvement in memory. There was a study with a keto ester drink where they saw some improvement in exercise. And the other area where ketones can have therapeutic potential, especially ketone supplementation for different psychiatric disorders, because of all the mechanisms that I described before, including reducing oxidative stress, improving GABA level, ATP level. These will all lead to helping the psychiatric disorders. And indeed, there are several patients who reported with bipolar disorder that after starting ketogenic diet or ketone supplementation, their condition changed a lot. Some studies were done on autism and ketogenic diet, which showed some improvement. And depression, schizophrenia, and anorexia are also very promising targets. And as I mentioned, the metabolic psychiatry is already a separate field of science. And again, it's just interesting to see that the depressed brain, how much it's similar to the Alzheimer's brain compared to the not depressed brain. So the glucose utilization is impaired there too. So we definitely want to get some ketones there. So migraines, again, the same problems happen during a migraine. There is a mitochondrial dysfunction, there is an oxidative stress, inflammation. So we already went through all these processes that beta hydroxybutyrate molecule can actually improve all that. Traumatic brain injury or concussion, people who are exposed to concussions due to their work, for example, or they got in a car accident, or they play sports like either hockey or football, anything like that where they are exposed to concussion. It can be applicable, and indeed a couple of studies showed that ketosis definitely reduce the mortality after CNS damage, similar to concussion. And actually there is a study going on in the Oslo hospital on TBI patient, where they use the ketogenic diet and the ketone salt supplement, and this study is under review right now. Stroke patients, again, the same idea. They used ketone salts to study a stroke model, and they saw significant improvement. Another study, spinal injuries, saw a significant improvement. So by that time, I feel that many of us can kind of relate that we really want to increase ketone levels in our body somehow. So what can we do? What are the ketone metabolic therapies that we can do? For some of us, the easiest, for some of us, it's the hardest, is fasting. So we can do water fast, which you can do, but after a while you have to stop. You can't fast too long, right? And once you stop it, your ketone level is going to drop again. I know. So the other option, you can do a diet-induced ketosis, but the problem again, many people don't know exactly very well what is the ketogenic diet and how to follow, what has carb and how much. And the other problems, sometimes people overconsume calories. They think they are eating ketogenic diet, or just by lowering carbohydrates, it's still not a ketogenic diet. If you are eating over 60% of the calories as fat, then you are starting to do the ketogenic diet, but most people just don't consume enough fat to be called ketogenic diet. So there are many issues. Obviously, many products put on their packaging, it's keto, and people think they are eating keto stuff, which is not even keto. Like 80-90% of the keto called things are not actually keto. So, and in addition, some older people, sometimes they want to eat what they want to eat, and it's just hard. I don't know about my parents and some other friends. They just want to eat what they want to eat. So what can we do? Sometimes when people follow correctly the ketogenic diet, they experience a high cholesterol, they get stressed about that, or their doctor gets stressed about that. Or if they increase the protein level, then their ketone level will drop again, and it's not there. The other option is probably the easiest for most people, following a low-carb diet, so you prevent the glucose spikes, but still you're not going to get ketone elevation. For that, you can use ketone supplementation. And I'm going to talk a little bit about ketone supplements, because I experienced there's a lot of misunderstanding and misconceptions about ketone supplements. So there are ketogenic precursors, medium chain triglycerides and 1,3-butanediol, and there are exogenous ketones. And I want to point out a couple of red flags because I know that many people were burned by ketone supplements, and that actually made me upset that some companies destroy the reputation of this technology and the molecule by offering products that are not very effective and actually create bad experiences. So just want to point out a couple of things when you're looking for a ketone supplements, what to look for, what to pay attention. If, for example, they put on the label proprietary blend, that means there's a lot of stuff in it, and they don't want to tell you how much BHB is actually in that blend, so they can get away with a little bit, and so you're not going to really actually get a benefit from ketones. So you want to have a clean, written out how much BHB is in the product. Some products are claiming there are 12 grams of ketones in the product. Well, if you look at it, it turns out it's just 8 grams of MCT, which is not actually a ketone, it's a ketogenic precursor. Sometimes they put 1 or even less than 1 gram of ketone in a serving, for example, in pills. So if you see pills, that most likely not going to do anything because it can't fit in a pill more than 1 gram, and that's probably not going to be enough to do much. Sometimes you get products that have too much magnesium, so you have to run immediately into the bathroom. Again, this is for most of us not a good experience. Sometimes they put too much caffeine in it, like 300, 400 milligrams of caffeine. You will feel energy, but not from the ketones. Or they put in other stimulants in it. Again, you're going to feel energized, but not from the ketones. You're not going to get all the benefits that I explained before. For example, the medium chain triglycerides are very accessible. You can buy them anywhere. MCT oil, MCT powder, they induce mild ketosis. To achieve a reasonable amount of ketosis, you have to consume a lot, which leads to GI distress mostly. And these are ketogenic precursors, so your body has to break it down to create ketones. 1,3-butyl is also a ketone precursor. Sometimes they market it as ketone ester. It's not. Sometimes they are marketed as alcohol, ethanol-free alcohol, which also points out the problem with it. It puts pressure on the liver, so your liver has to work hard to break it down, and it can be mildly narcotic. So we don't recommend it to older people because it increases the risk of falling. And also it tastes like jet fuel. The other option we have here is the free acid BHB, which breaks down fast, doesn't stay in the bloodstream long enough, it's very unstable, it has low efficacy, and also increases blood acidity, which sometimes we don't want. Ketone esters are very effective to increase ketone levels quickly, but as I mentioned before, your liver has to work hard to break it down, and it puts pressure on the liver. I wouldn't recommend chronically use it because of the liver issue. It also causes stomach distress, nausea, dizziness, and higher doses can increase insulin. We heard about insulin today. We probably don't want to increase that, and also tastes like jet fuel. The other option is ketone salts. BHB, the beta-hydroxybutyrate molecule that is combined with electrolytes. So basically you get 2 products in one. You get your minerals, electrolytes, sodium BHB, potassium, calcium, magnesium, and so it serves as an electrolyte replenishment, doesn't increase insulin, and doesn't put pressure on the liver because it is already the BHB molecule that you want. Not all the product tastes good, some of them are, so it can be formulated that it actually tastes good. Some misconceptions about exogenous ketones. For a long time, I always heard people that they just want to elevate ketone levels as much as they can. They think that higher ketones are always the best, which is, we are finding, not always the truth. Some people think that the D BHB is better than the L, and I'm going to talk about that, why that's not true. They say ketone salts are less effective. I'm going to show why it's not true. And they also sometimes say that too much salt is bad for you, which we already heard about it today, that it's not always true. So we did some experiments, and more often we see that sometimes higher ketone levels are not good. So for example, these are cancer cells. We treated them with different concentrations of ketone supplements, and we saw that the lower concentrations were very effective to reduce the glucose transporter on the cancer cells, which is a good thing. But if we increase the ketone concentration, there was some kind of compensatory mechanism, and it wasn't as effective. Another experiment, similar idea, the anxiety test. We did a test where the rats spend more time in the light area of the box. They are less anxious. If they spend more time in the dark area, they are more anxious. We saw when we used a lower dose of ketone supplements, it improved the anxiety of the rats. They spent more time in the light area. When we used higher dose, this effect changed. So apparently here again there was some kind of compensatory mechanism that started. This is a human data. Here we used BHB salts and ketone esters, and we saw that we could increase the BHB level in the blood approximately in a similar way, but when consuming the ketone ester, it significantly increased the insulin level, while it didn't happen when we used the beta-hydroxybutyrate salt. So based on the current research, we think that the optimal ketosis is somewhere between 0.8 and 2. And for most applications, we don't really need to elevate the ketone or the blood ketone levels higher than 2. A little bit about the difference between the D and the L. The D BHB and the L BHB molecules are basically like a mirror image to each other, so they're very similar. The trick here that the body makes only 2-3% of the L. So when we supplement it with a supplement, for example, has 50% D, 50% L, we can elevate the L-BHB level in the blood, which has additional benefits I already mentioned. But the ketone monitoring devices can't measure the L form yet. So if you take a supplement that has L in it, and you take a blood measurement with any of the ketone monitoring device, you will only see the DBHB. So it's not that it's not effective, the ketone salts, but the current technology cannot measure the LBHB yet. So you have to pay attention when you use a product like that. And here there was a study where they gave the LBHB to rats, and they monitored where these molecules went. They saw that the D molecule went to the heart and the liver, mostly increased the BHB level, but the LBHB also went to muscles and the brain too. So here you have to remember, when you want to target any of the problems that the brain is involved, you want to have ketone salt that has LBHB in it. We already talked about this today. Sometimes people think that too much salt is a problem, so consuming ketone salts must be a problem. We already talked about it that on a low-carb diet, we need usually more salt, and also new research shows that probably 3,000, 4,000 milligrams per day is the more ideal dose for most people. And if you do strenuous exercise, then you need even more. This is a study that we did, our Hungarian collaborator, and just wanted to point out how important it is to consider that every individual is different. So if you consume ketones and the other person is going to respond differently, that's completely normal. There is age and sex-dependent difference. How do we react? We did a study, and with age and with gender, the responses were different. So, and also I wanted to here quickly point out the adaptation. So somebody who's who get used to the ketogenic diet, the ketogenic lifestyle, they will probably use the ketones better than somebody who's just trying it out first. So if you have less ketones in your body after consuming a supplement, probably it's because your body already is used to using that molecule. And if somebody never tried this before, maybe their ketone level will be more elevated after taking the supplement because their body is still working to get used to using these molecules. And I just wanted to show a couple other applications that are not definitely related to neurological problems. And I also wanted to point out that some of this information is summarized on flyers. So when you go by the door on the table, you found 2 flyers. One is like that with additional information, and one is like that with additional information to summarize some of the things that I told today, to have some takeaway information. So what are the next steps? We probably have to work on developing even more potent formulation. We have to think about slowing down the process or even preventing disease progression, not just starting these treatments after the problem is already there. We have to differentiate between early stage and late stage of the neurological diseases. And also we have to study long-term safety. Most of these studies are using maybe a couple weeks or a couple months data. If we want to use either the diet or the supplement for these specific problems, we need years-long data. And probably the most promising compound, the ketone salts, were not yet tested for Alzheimer's disease, MCI, and Parkinson's disease. So there's much more to do in the future. And thank you for